Bismillahirrahmanirrahim. Today's video is about step response of an RLC circuit, and here we'll be solving practice problem 7.15, and this is on the request of a student. So I'll strongly recommend that before you proceed further, you must watch my video on example 7.15. That will make things very clear. Anyway, let's proceed. So this is practice problem 7.15, and for this circuit we have to find Vt and V02. Now Vt is the voltage across the capacitor and V0t is the output voltage. Okay, so first of all, let V1 be the potential at the inverting terminal. So I've just marked these, calling this V1 and this V2. And this formula we should be familiar for step response of a RLC circuit. This is the formula that we use. And in this formula, we have to find these three things: tau, V0, and V infinity. First of all, tau is the time constant, which is equal to R into C. And R is basically the resistance across this capacitor. So 100 kilo multiplied by 1 microfarad will give us 0.1 second. So one parameter we have found. Now the second one, for t less than 0, the voltage across the capacitor is 0. Now t less than 0, we open this circuit, and that means this voltage does not have any effect on the capacitor. So the capacitor will not charge. And so the capacitor voltage will be 0. That means here we can write that V0 is equal to 0. So second point we have found. Now we need to find V infinity. And before finding V infinity, let's find this formula. Learn this formula. From here you can see that V1 minus V0 is equal to V. But V1 is 0 because V2 is 0, and we know that V1 is equal to V2 always. So since V2 is 0, therefore V1 is also 0. Since V2 is 0, why 0? It is grounded. So V2 0 is grounded, therefore V1 is equal to V2 is equal to 0. So V1 0 will plug in into this, and therefore V is equal to minus V naught. And this is our equation number 1. We'll be using this equation. So we got to keep in mind that we need to find Vt and V0t, and we were trying to find V infinity. Now for V infinity, we have to close this switch for t greater than 0. The switch is closed and the capacitor is charged. So this capacitor is charged with this voltage, fully charged, and it will now behave like an open circuit. When it is fully charged, it behaves like an open circuit, and the operational amplifier is behaving like an inverting amplifier. Now, how? Let's see. In chapter number 5, we have read this as an inverting amplifier. You see there's an input source connected through resistance to the negative terminal. Same in our case, through resistance connected to negative terminal. Then we have a feedback resistance. So we can say that this is also inverting amplifier. And in an inverting amplifier, we have learned this formula, that V0 over Vi is equal to minus Rf over Ri. So we use this formula now to find V out, which is minus Rf Ri or R1 into Vi. So in case of infinity, we will now can write V infinity The resistance RF is 100 kilo and R1 is 10 kilo, and our input is 4 millivolt. So V infinity or V out infinity is minus 40 millivolt. Okay, and now since V is minus V0, therefore from here we can find V infinity. Remember that our aim is to find V infinity first. V infinity is minus V0 infinity, which is equal to 40 millivolt. Just minus minus plus. Okay, so now we are ready to apply this formula. We have tau, we had found V0, and we have found V infinity. So plugging in the values, we get this equation. And from here, we take 40 common. So this is 1 minus e raised to the power minus 10t. Now, when you divide 1 by 0.1, it will become 10. That is why it is minus 10t millivolts. So this is the first answer. And now VOT, we just simply use this formula. VOT is minus V 0. So V0 will be minus VT. So VOT will be now minus of V. So minus of this answer, which will be 40 e raised to the power minus 10t minus 1. See that the difference, this one has come first now. I hope you have been able to follow this. Please let me know through your comments. Thank you.